Je suis très heureux de pouvoir poser une question à Igor Levin lui-même concernant les AFX qui sont vraiment des outils pour moi fantastiques. Et je voulais lui demander comment il s'était débrouillé pour que les AFX sonnent aussi bien, mieux que les plugins natifs. Et j'ai en tête un exemple, je vais lui demander à propos de l'EQ Pultec, qui pour moi est la meilleure modélisation de Pultec que je connaisse. So Igor, I'm really happy to be able to ask you one question.
I heard
How
that
di-
in French, and I
oh,
guess
you
my French is
understand.
not great, but I
But you
got that
understand. So
that you think that this is the best full tech
yeah,
implementation that you've heard,
yeah,
right?
because I compared it to
Yeah.
UAD, which was really harsher and with more distortion for me. And I used to, yes, to use the Waves Tech native plug, which sounded nice to me, sweeter. But when I tried for the first time the Pultec in its AFX FPGA powered version, I had the sweetness of the waves, but more detail with more impact, more low end, and absolutely no nasty distortion that I had experienced with UAD. So I don't want you to tell me your secrets, but I want to understand how did you achieve such a great result?
Well, I guess the interesting question is, did we achieve the great result, or did other people not achieve the good result? Because it's relative. So in some sense, by saying, okay, we sound better, that also says that, okay, somebody doesn't sound as good as us. And I don't know, to what extent is it that we're doing something amazing, or is it other people are not doing as good as we? And since I don't really know what other designers are doing, it's a little bit difficult to comment on that. Our approach is pretty simple. I mean, the way we do these things is we get the original schematics and we get the original devices, and then we model these things first in the analog domain, and we use SPICE, and we also use extensive measurements when these things deviate. And so the trick is, I think, is to understand what the circuit is trying to do and how the circuit is doing, as well as to understand what the imperfections of the circuits are.
So you have to reproduce the imperfections too,
In some
the
sense, and
character.
I guess the trick is to know what to reproduce, because engineering is sort of an art of compromise. In essence, what you're doing is you're choosing carefully
Yeah.
which imperfections you should model and which imperfections you should not model, and that's where the judgment call comes in, because that's something that some people have and some people don't have. And what I found, and it's an interesting thing, like I'm an analog engineer, my background, when I started out, of course I'm old enough when analog used to be the main type of electronics.
For sure.
And so I come from that background, the first 10 years I spent designing analog circuits, special advanced analog circuits. And in fact, I worked in biomedical.
Oh,
So I used to do things for, brain signals and,
wow.
and so there are some challenges, interesting challenges in terms of the signals are small, there's shielding. It's interesting. It has a lot in general with audio, but the main thing is you learn a lot of advanced techniques like noise and distortion um, and so on. So electronics, analog electronics, to me is my first language that I learned in electronics.
People don't know that generally. They think of you about the clock expert, so digital world, and they don't always know about your analog
It's
background.
interesting, yeah, it is, because so much of me is associated with the clocking, which was really sort of my major big breakthrough. But I've designed a lot of analog circuits, and I guess as you can now see, because a lot of the stuff we have now has mic pre's and monitoring controllers and DACs, and there's analog circuits everywhere. Even in the power supplies, there are special analog techniques that must be used. So I think in my case, having the background of understanding the analog electronics and having huge experience in it makes the difference when it comes to choosing what matters and what doesn't matter. So I think that that's step number one. Step number two is actually then figuring out what sort of modeling methods you're going to implement, because there are many different mathematical ways to do something. And again, each topology, just in digital filters, there's different kinds of filters. There are wave digital filters, there's IARs, there are FIRs, there's You know, there's so many choices, even in a digital domain you would make when you choose how to model. And then the next thing is, okay, resolution. That's another thing is, you know, computing these things, the quality of computation, and where you need more resolution, where you need less resolution. When we make this FPGA stuff, we actually tailor it. It's handmade to model these things. And the modeling, it's the hardware that models the hardware. It's not just you know, software running and solving equations. It's actually hardware blocks built to solve these things. They're hardware solvers, and it's the hardware that models the hardware. That's maybe why it feels more like the real hardware, and sometimes it has the quirks of the hardware. So maybe those are some of the things, you know, without telling you all my secrets.
No,
but basically,
but that's cool. I guess that you measured many units, because vintage units, it's okay, nostalgic, nice, but they all sound different, probably slightly different.
Yeah, I guess it's like the French wine, right? So
exactly.
I guess if
like
it's Chardonnay, you know,
Chardonnay,
in
Saumur.
2000, you know, 9, is it all the same? Maybe not, right? So I guess I don't overdo this thing with the measuring all kinds of units, because you can also go crazy about this stuff. And then ultimately, how will the person know? You know, it's interesting. You also, you know, which one should you choose? Because at the end you end up, okay, and we had this issue with the microphone modeling, you know, it's even more so because microphones, the membrane, it ages, plus the humidity and the conditions, you know, it ends up affecting things. So it's a little bit interesting. You know, you can really go crazy figuring out, do you really want this microphone or that microphone? Or in this one, the tube is a little bit older. In that one, the membrane is been changed, but the tube has been aged. And, you know, and that's sort of these discussions, how like our models sound like this and Steven's models sound like that. You know, it gets into, I think at some point it's a little bit, again, of a judgment call, or just sometimes it's random. We just got this microphone that somebody is using and they've been really happy. They've done great recordings with it. And we don't know if this is necessarily the most representative microphone.
But it sounds great.
But that's the one that we got. And sometimes it's a bit of a luck thing.
I guess. Oh, thank you very much.